Kia ora Year 13. I'm going to YouTube the 2015 distributions paper just in time before the Level 3 Stats exam. So here's question 1a. This is a pretty straightforward uniform distribution question. So I've just given away the answer to the first part, but never mind. Alright, at train station A, the time it will take for the next train to arrive is between 2 and 12 minutes, and here are the keywords, with all times in between equally likely. So as soon as you read that, you should be thinking, okay, uniform. And at train station B, the time taken for the next train to arrive is between 4 and 9 minutes, with all times in between equally likely. So we have to use an appropriate model to sketch each distribution on the same axes below. And they're very nicely given you some nice little squares, which we've got here. So we might as well do one per thing, and we're going to make this time here, we'll call that T. Train A, just make that a bit nicer, is going to arrive anywhere between 2 minutes and 12 minutes. So 2, 4, 6, 8, 10, 12, there's 12 there. Now we need to think about what the height is. So for a uniform distribution, we have a rectangle. Because it's a probability distribution, the area of that rectangle must equal 1. So here we've got 10 minutes there, so length times width must equal 1, so it's going to be 10 times the height of the thing. So the height for that one is 0.1. Okay, so we'll make this 0.1 here, and there's my probability distribution. Okay, so that's for train A. We might just label that A. Okay, for train B, we'll use red, and the time it's going to take is between 4 and 9 minutes. So again, the area of my distribution has to be 1. I can mark on 4 here and 9 here. Right, so there's a 5-minute gap here. So my rectangle is going to be a different shape. It'll be 1 equals 5 times the height, and the height must equal 1/5 or 0.2. So this rectangle is going to be twice as high as the other one. 0.1, 1, 2, 3, 4. Here we are. We'll put it here. There. Right, so they are my two distributions. This one is train station B. This one is train station A. If you look at the schedule and what the markers were looking for last year, I think quite a few students probably didn't put the heights on, or they did put the heights on, but they didn't actually figure out what were these numbers here. Okay, and so you should make sure that you're doing that if you're working with a uniform probability distribution, and if you're working with a triangular, make sure you find the peak height. It's just a piece of information that you're going to need to solve any problems for that situation. Okay, so believe it or not, that was a little merit tick, which was, I think, on the generous side, but I wouldn't really know. Next, we have to solve a couple of problems about this situation. Oh, another graph. Okay, calculate the probability that it takes more than 8 minutes for the next train to arrive at train station A, and more than 8 minutes for the next train to arrive at train station B, and give any assumption or assumptions that need to be made. So the first thing is, if you want to, you can think about this as a tree diagram. So more than 8 minutes for A, and then we need to have more than 8 minutes for train station B. So to be able to do this, we need to assume that the waiting times are independent. Okay, because we don't have any information about how the chances that the train at A is taking a long time to come affects the train at B. So we're just going to have to assume independence of waiting times, so we need to state that. As usual, make sure that you're stating that in context. So pretend that you're explaining that to someone who hasn't done any statistics. So we assume that the arrival times or the waiting times for the two trains are independent. So this is your key word here. So the next thing we've got to do is the probability that A is greater than or equal to 8. So we can sketch out what we had for A. A was our flat one that went from 2 to 12. In the exam you'd have this here so you could have a nicer diagram, but it looks like that. So the area of this rectangle has got a width of 4, and we know that the height here was equal to 0.1, so that probability is 0.4. Similarly, we can work out the probability that the train at station B takes more than 8 minutes. The B picture is the tall, skinny one. So it's this kind of rectangle. The area will be, so there's 8 and 9. So the width is only 1 and the height is 0.2. So that's equal to 0.2. And our problem requires us to work out the chances that both of those things happen. So we're going to be multiplying those two together, and I'll just do that on a new slide. Okay, so the probability of A greater than 8 times the probability that B is also got a waiting time of greater than 8 is going to equal 0.4 times 0.2, which is 0.08. Alright, to get merit on this question, which was another code, you had to work out this probability, and you had to give the independence assumption, and you had to give it in context. Alright, so that's all for now. I'll be back with part 1b soon. Thanks for watching.